The data are numerical, and the question was, how many hours per week do you work? And there are 15 students here. They give you the 0.05 level of significance, and we're going to test a claim. So this just goes into what we've done in the past with testing claims. But this one is going to test a claim about a median work hours instead of mean work hours. And whenever a test is made about a median, you want to go to this section, 15.3. And the claim is that the median work hours is more than 12. More than 12. So the hypotheses would be the median equals 12. And the alternative hypothesis would be our claim that the median is more than 12 hours per week. That's the claim. And M is equal to the median work hours per week. So there's the hypotheses. Here's the level of significance, alpha. And the next thing we have to do is to calculate the test statistic and the p-value, and that's going to help us with the conclusion. All right, one thing you might want to do with these numbers is to rank them, from smallest to largest, because the sample median is certainly something that you'd want to calculate here. It's the middle data value. If there are 15 students, then the middle one would be the 8th one, but that's only if you order them from smallest to largest. So let's see, we have 9 and 10 and 11 and 12, and then it looks like a couple of 13s. And a couple of 14s. And looks like 3 15s. A 16. A couple of 18s, and then a 20. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8. So there's the median right there. The sample median is 14. Is the median larger than 12? I don't know. Sample median in this randomly selected sample is, but is that enough evidence to enable us to reject that, or to support that the median is larger than 12? Okay, so here comes the sign test. 12 is our mu0 value, and so we're going to compare 12 to each one of these numbers. 9 is less than 12, 10 and 11 are also. I'm going to put a 0 next to 12 because 12 is actually equal to this number in the null hypothesis. And all of these other ones are larger than 12, so I'm going to put a plus sign next to all of them. And then we're going to do this table. Number of negative signs, number of positive signs, and the number of zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 plus signs. 1, 2, 3. 3 minus signs. And 1, 0, because they're equal. And when you add those 3 numbers together, you get 15. However, when we do this test, n is going to be equal to the number of plus signs plus the number of minus signs. So even though 15 students took part in this study, when we calculate our test statistic and our p-value, well, actually our critical value, we choose n to be the sum of just the pluses and the minuses. All right, so, and then k equals the number of minuses, 3. This is our test statistic. The next thing we need is the critical value. Alpha is 0.05 and n is 14. You'll need to get your tables out. So go down where n is 14. And then we have a one-tailed test where alpha is equal to 0.05. 0.05 and one tail, I think. Is that right? Yeah. So it's a one-tailed test. This is the greater than. And alpha is 0.05. One-tailed, 0.05. Go down to 14. And there's the critical value, 3. Since k is 3 and the critical value is 3, the test says if the test statistic is less than or equal to the critical value, then we reject the null hypothesis. So if the test statistic and the critical values are equal, then they are less than or equal to. Then k is less than or equal to the critical value if the two are equal. So we're going to reject the null hypothesis. There's evidence to support the claim that the median weekly work hours is greater than 12 hours. There it is. There's no confidence interval in this one because we do not have a parametric distribution. And because we don't have a parametric distribution, we can't do a classical approach by drawing a graph because there is no graph. But we can use critical values. Why don't you try number 2? In this example, we have 10 data values. And so here I've taken these 10 data values and ordered them from smallest to largest. So the median would be right between the 2 middle data values. So the sample median is equal to 209.5. Here's the claim. Determine if the reading class is effective. Well, if you read this one here, they came in and they were able to read 199 words per minute. So if the reading class is effective, then when they exit and take the test at the end, after going through the reading class, they should increase their words per minute. So the median greater than 199 is the claim. So you have to turn this claim or this question into a mathematical statement. So it involves reading the entire problem. WPM words per minute. Prior to the class, the student was able to read 199 words per minute. So that's how we define the median. Median reading rate in words per minute. All right, 199 is here. So this gets a 0. And then we have 2 minuses and the rest pluses. the sign test, because we put a sign plus or minus next to each data value. K equals, oh, I don't know. Zeros we have 1, minuses we have 2, and pluses we have 7. So again, another example where n turns out not to be the 10 that we originally started with, because we only add the pluses and minuses. So k is equal to the number of minus signs, just like up here. And that's going to be the case if you have a greater than test, as we do in both cases. Greater than, k is the number of minus signs. If we're less than, then we would choose the number of pluses. N is 9. Alpha equals 0.05, one tail. That's the far right column. And then here is your critical value. .05, one tail, all the way down to 9. So, critical value is 1. K is 2. K is greater than the critical value, because 2 is greater than 1. And if k is less than or equal to the critical value, we reject. But if k is greater than the critical value, we do the opposite. Do not reject. The null hypothesis. And if we're not going to reject, we're not going to have evidence to support the claim that the test is effective on average. Oh, one thing I didn't do is I didn't calculate the p-value in these. Okay, so in the first one, the p-value is binomial CDF. You've got the n value, which is 14. The middle number is 0.5, because if the median is in fact 12, exactly half will be above 12. Well, these data values will be above 12 and exactly half will be below. That's the definition of the median. And then, so p equals 1/2 always for this test. And then the last number you're going to put in there is the k, the test statistic. So what's the probability of getting our test statistic 3 or something more extreme? And we punch that into the calculator. Find the binomial function, 14 and 0.5 and 3. So number of trials is 14. The probability value is 0.5. And I don't know what they say here, X value or data value or something like that. But notice it's 0.029, let's call it. And if you compare that p-value to the alpha value, p is less than alpha, so reject. And that's what we decided here. So again, there's a p-value approach to reject. There's also a critical value way to reject. And for this one down here, I guess I'll do it right here. The p-value is binomial CDF. Again, the n value for this one is 9. We're always going to let p be 1/2. All right, so 0.5. And then the k value is 2. So for this one, start off with 9 and then 0.5 and then And that's 0.0898. So in this case, we have P is 0.0898 and alpha is 0.05. And P is greater than alpha, so do not reject. Again, using the p-value is just another way to make the decision that's different than the critical value approach.